Hello, and welcome to the final webinar in the 2020 Virtual Summer Learning Series for secondary mathematics educators from the Indiana Department of Education. My name is Robin Conti, and I am the Assistant Director of Teaching and Learning at IDOE. This slide deck will be available for you on the Mathematics Standards page at doe.in.gov/standards/mathematics under Professional Learning. Sixth grade teachers can benefit from both elementary and secondary, depending on how your district is set up at the middle level. Today, we will explore an instructional routine that instantly ignites creative and critical thinking in students. Which one doesn't belong? Throughout the virtual summer series, we have two purposes. First, we want to explore high-quality math resources that are aligned to the Indiana academic standards to aid in improving teaching and learning of mathematics for all students. What is important to note here is that high quality does not equal complex. Our goal is to explore resources and routines that do not require a heavy lift for educators to implement. Second, we hope that you will discover for the first time or learn ways to refine your current understanding of ways to integrate the specific resource into your instructional routine, both virtually and in person. Let's run through an example together before we get started on the details. I encourage you to pause throughout the webinar to reflect and consider your own classroom implications of the instructional routine. First, let's talk a little about wait time. Research shows the average length a teacher waits is 0.9 seconds. The fastest 100-meter sprinters in the world run at 10 seconds. The world record is under 10 seconds, and that is fast. We should at least be able to offer our students 10 seconds to consider responses that require deeper thinking. You know your students best and how much time they need, but I suggest starting with at least 30 seconds. You can work up to longer times and build student stamina, but it requires practice. I also suggest using a visual timer for both you and your students. Ask students to be respectful of each other's think time and not share their thinking until the timer is done. Students need time to process the information on their own before considering the thinking of others. Some guiding questions you may ask include, what do you notice? What makes all the items alike? What makes them different? Which one doesn't belong? And can you share your reasoning to justify your answer? By now, most of these questions should sound familiar. Think about why a student would choose a particular set of numbers to say the pattern of numbers does not belong. What would their reasoning be for each? Think ahead, but also plan to be surprised by what they notice. Once the timer has stopped, have students share out with a partner or in small groups. Finally, have students share their thoughts with the class. Some responses for this one may include, the upper right box does not belong because it is the only one being multiplied. Or, the bottom left box does not belong because it is the only one with a negative. Someone could also say the bottom right box does not belong because it is the only one decreasing. You may also find a student say the upper left box doesn't belong because it's the only one that doesn't have a pattern. That one really can spark some conversation. This instructional routine was inspired by the Math Twitter blogosphere, MTBOS, and Christopher Danielson, who wrote Which One Doesn't Belong, a Shapes book, and hosts Talking Math with Your Kids on Twitter. Christopher Danielson saw a need for math books that gave opportunities for rich conversations and challenges students at the same way literary stories we read do. The website is dedicated to providing thought-provoking puzzles for math teachers and students. The routine offers visual and thought-provoking puzzles that offer an opportunity for all students to engage. There are no answers provided, as there are many different correct ways of choosing which one doesn't belong. Steve Wyborny had a similar idea in 2015 called imposter sets. Imposter sets provide an opportunity for students to investigate and compare and contrast math concepts. Students are tasked to determine the imposter by looking for the math property that is shared by the other three numbers. It is possible for multiple numbers to be the imposter based on the math property the student determines. In imposter sets, you ask students, how do you define and defend the imposter? Instead of simply, how did you find the imposter? There are many similarities between imposter sets and which one doesn't belong. The link to the website with imposter sets is included in the slide deck. Same but different is another similar instructional routine. It provides a collection of images to encourage grayscale thinking or the ability to see the world as having middle ground versus black and white. For example, there is not just short and long, but many lengths in between. Categorical thinking, or the ability to attend to the features of things and how to connect something new to something we are familiar with, and help students build a network of ideas for learning and thinking about math. When exploring the Shapes tab of the Which One Doesn't Belong site, you will notice that it does not simply imply shapes. You could use this one if you are going to solve right triangles using trigonometry. Do not discount using a shapes image such as this with secondary students. Or you may find images like this, which would be great to use when introducing the concept of multiplying binomials or even completing the square. When exploring the Numbers tab, you will find puzzles that can introduce x as an exponent for the first time to your students. You will find ones that have simple numbers on them. This one would be a great one to use if you are dealing with prime and composite numbers in early middle school, or getting ready to simplify square roots of non-perfect squares. Finally, you may find puzzles that have ratios written in this form. This may be a great one to do if you're teaching geometry and getting ready to talk about scale factor. Finally, under the Graphs tab, you can find equations of graphs.
Finally, you have the Complete Set. In the Incomplete Set tab, you can find a rich experience by removing one box. By removing one or even two, you have created a challenge to your students. The cognitive load is completely shifted and increased for students. Simply remove one box from any of the complete sets and ask students, what do you think belongs there?
You can use Which One Doesn't Belong puzzles as warm-ups for just-in-time teaching. Students can write their response on a Post-it and place it on the smartboard, board, etc. You can give students a sentence stem to help, like, the number blank does not belong because. I encourage you to vary these within the progression of your lesson, not only as a warm-up at the beginning of your lesson, but also as a brain break in the middle of an intense lesson where students need a break. You're still incorporating the standard or skill, but in a more interactive and engaging way. You can also use these at the end of your lesson as a formative assessment to inform your instructional decisions for later lessons. Provide students an incomplete set that ties into the lesson of the day as a ticket out the door. This is a great formative assessment method. You can gather a lot of information based on what students respond with. If you feel they missed the mark, then instructional changes may need to occur for the next lesson. Allow students to create their own to show understanding of a particular concept. Students will find the first two or maybe three boxes easy, but that fourth one makes them think. Again, the cognitive load has been elevated and the deep thinking begins. Some of my favorite go-to sites for interactive virtual math instruction is Desmos, Nearpod, and ClassKick. There are several Desmos Which One Doesn't Belong activities, and Desmos Coronavirus and You has starter screens such as How Are You Feeling Today? To copy and paste, webinars, trainings, resources for distance learning by grade, and more. Another great strategy is to ask students to take pictures of places in their community to create a Which One Doesn't Belong to share with their class. If you are a Pear Deck user and have access to the premium features, you can explore the Pear Deck draggable slides. To edit the type of question, go back to the Ask Students a Question in the Pear Deck sidebar. Choose Odd One Out template and insert 4 images that have different things in common. If you do not have access to Pear Deck, this could easily be adapted in Google Slides. Finally, follow the hashtag WODB for more puzzles for all types of learning. Now that we have familiarized ourselves with the in-person and virtual opportunities of the Which One Doesn't Belong routine, I'd like to share a few tips that will help enhance the teacher and student experience. Each object in a Which One Doesn't Belong set has at least one reason not to belong. There is not one right answer. With that in mind, it is important to validate all responses. Saying yes does not mean you're right. Rich math talk depends on students feeling safe and their ideas valued. If a claim is true, it is correct. Press for precision. Students will need help learning to express their ideas precisely. Ask questions to ensure that you and your students understand the exact differences or similarities under discussion. Be sure to use precise vocabulary. Speaking of, seize the opportunity to insert vocabulary. Introduce vocabulary when students need it. Students often notice properties they don't know names for. Use these opportunities to introduce vocabulary. Finally, give students time. Make sure students have the time and space to do their best thinking. No hands raised, no talking, no pressure for about a minute before. Specific math content will vary, but let's suppose you are an Algebra 1 teacher. Suppose your current grade level standard is A1, L3, representing linear functions as graphs from equations, equations from graphs, and equations from tables and other information, and find the equation of a line passing through a given point that is parallel or perpendicular to a given line. You may choose to use this Which One Doesn't Belong as an introduction to the lesson. By intentionally choosing this particular puzzle, you have an opportunity to draw upon students' prior knowledge of 8AF5. You can listen for vocabulary use or lack thereof. You may even have students sketch the graph of each equation to review graphing, ending by asking the all-important question, what do you notice? A great resource to help you with planning is the Math Framework. The Math Framework offers a looking back and looking ahead section that shows you the vertical alignment of standards. Utilizing this part of the framework can help you choose tasks that best fit your students' needs and recognize the prior knowledge needed that can be used to build understanding of the grade level target. The specific puzzle used may expand the mathematical practice possibilities, but in general, this routine will encourage students to use Process Standard 2. Reason abstractly and quantitatively. Mathematically proficient students make sense of quantities and their relationships in problem situations. They bring two complementary abilities to bear on problems involving quantitative relationships: the ability to decontextualize, to abstract a given situation and represent it symbolically, and manipulate the representing symbols as if they have a life of their own without necessarily attending to the reference, and the ability to contextualize, to pause as needed during the manipulation process in order to probe into the reference for the symbols involved. Process Standard 3, construct viable arguments and critique the reasoning of others. Mathematically proficient students make conjectures and build a logical progression of statements to explore the truth of their conjectures. They analyze situations by breaking them into cases and recognize and use counterexamples. They organize their mathematical thinking, justify their conclusions, and communicate them to others, and respond to the arguments of others. And finally, Process Standard 6, attend to precision. Mathematically proficient students communicate precisely to others. They use clear definitions, including correct mathematical language, in discussion with others and in their own reasoning. They express solutions clearly and logically by using the appropriate mathematical term and notation. Which One Doesn't Belong promotes a respectful learning community by creating a culture of valuing students as thinkers, reasoners, listeners, justifiers, and doers of mathematics. Diverse thinking is valued. Each Which One Doesn't Belong is designed to be interpreted in a variety of ways, and because all answers are correct, students naturally shift their focus to justifications that spark deep mathematical thinking and discussion. Some of what students learn in school is considered just in case. Content is sometimes taught just in case they need it later in school or the workplace. Once students determine a college major or start their first job or gain an interest, they begin learning just-in-time content, the things you need to learn when you need to learn them. Just-in-time learning is highly motivating. You begin to understand that you must learn some things before you can apply your learning. Which One Doesn't Belong allows for just-in-time teaching, accessing content that is needed to accelerate the grade level content coming up in the lesson. Students are actively engaged in reviewing material, and it gives the educator information on students' existing knowledge before teaching begins. Instructional routines are important for teachers to establish with their students. They help build consistency and a level of predictability that students often crave. When students are familiar with an instructional routine, they are then able to focus on their thinking and not on the next step of the process or in figuring out what question they are supposed to be answering. Instructional routines also benefit the teacher. Established instructional routines enables teachers to focus on their questioning and allow them to focus on student understanding. They allow teachers to listen to student thinking and not for the right answer.
Each school year brings its own unique set of challenges. The 2020-2021 school year will be no different. It is imperative that we focus on the acceleration of learning for our students, which is loosely defined by teaching and learning more than 1 year's amount of content within a single year. In order to do that, we must make a commitment to teaching grade level content while strategically and intentionally drawing on and reviewing prior content. Which One Doesn't Belong will support accelerated learning in several ways. Setting goals sets the stage for instructional decisions. Teachers must consider broader goals as well as the goal of the lesson. You should be able to answer questions such as, what is to be learned? Why is the goal important? Where are students coming from? Where do students need to go? And how can learning be extended? To implement tasks that create student exploration and sense-making, encourage students to ask questions and give time for exploration of new content by using a variety of methods and strategies. Talking and sharing are essential to effective instruction. Explaining ideas, listening to others, and asking questions help students make sense of their ideas. Provide students with opportunities to share ideas, clarify their understanding, and develop convincing arguments. By talking and sharing, you will advance the mathematical thinking of the entire class. When you are able to scaffold classroom discussions, you aid students in making connections between representations and mathematical ideas. You support sense-making, and you encourage students to explain their reasoning. It is important to assess student thinking and understanding through formative assessments in an ongoing manner. Eliciting and using evidence of student thinking, you are better able to access learning progress and make instructional decisions during the lesson. Be sure to pose questions and answer student questions that provide information about student understanding, strategies, and reasoning. Finally, be sure to use evidence of student thinking to determine next steps of instruction.
Copyright gives exclusive rights to the original work. Any work that is copyrighted is owned by a specific person, and you must gain permission to use the work. Educational fair use is an exception. It provides limitations without seeking permission from the copyright. Teaching falls under educational fair use. In its simplest form, you can use work that is copyrighted as long as it is not for profit or commercial use, is suitably appropriate, the work stays intact and original to its use, and its intended use will not affect the copyrighted material's value. This does not discount credit. You must still source and give credit where it is due. For example, this flowchart was adapted with permission from Art Class with LMJ. She created an educational fair use flowchart that I wanted to adapt to support math teachers, so I reached out to her and was given permission to her to adapt and use the resource in this way, but I'm giving her credit by linking the source in my document. Use the flowchart to figure out what path to take when using work from outside sources. Some basic rules of thumb include: if you did not personally create it, assume that it's copyrighted. If your use of the work will result in profit, distribution, or personal gain, you should always get permission first. If the work is not being used outside of class, you are typically safe, but it's always best to have the original resource cited and available. Thank you so much for spending time reviewing this webinar. Please reach out at my email on the screen or via Twitter with any questions or needs and support. Thank you